Yeah, good evening. Good evening, everyone. Good evening. Audio, video, okay. Good evening. Audio, video, okay. Good evening, good evening. Good evening. How are you? Surya, I'm absolutely fine. How are you? Good evening. Okay, good evening, good evening. Okay, so today NEET official answer key is released. Yeah, ready to learn new things. Yes, right. Naruto, ready to learn new things. Yeah. So, good evening to all of you. So, Mohit Sai getting less marks than cut off. No problem. Then start fresh and dream big. Think about to go aims. Okay. Okay. So, are you enjoying this ABC of chemistry? Marks are very less. That's why you are here, na? Marks are less. That's why you're listening to make it better, to improve something big in life. Okay. Those who are already in good marks, they achieved their goal, and those who are at less marks, they want to improve their life, they want to improve their marks, they want to be doctor in next year. That's why you are planning from the beginning. When people are thinking what to do and what not to do, you started your preparation. This is big thing, because if you started even before key is not released, means you are very sincere about your preparation. Otherwise, what most common mistake students are doing, they are wasting their lots of time just to take decision whether they have to start their preparation or not. And after two months, 1 month, when they start thinking also, it is sometimes too late. So if you started your preparation even before the release of answer key, it means you're sincere about your future. This is great thing. And these small efforts of today are going to create a big difference in future. So nothing is there like less marks came and okay, that is over. Whatever happened, over. Now plan for the future. And I think you already planned. And that will be reflected next year. That will be reflected next year. Sometimes we are learning, or not sometimes, even all the times we are learning by our failure also, if we are ready to learn. Okay, are you knowing about the Gukesh? Are you knowing? Sir, what are the expected cutoff? That will be given by Naren sir will explain everything. I think he already explained about the cutoff and everything. So he is better person to give idea about the cutoff and everything. Are you knowing about Gukesh? Yeah. Yeah, youngest world chess champion. Nearly 5 months back, when he defeated Ding Liren, and become youngest world chess champion. At that time, many people criticize him also. To whom? Many people criticize Gukesh. They said this was a fluke. Few said actually Gukesh won because Ding Liren did mistake. Few said this final match was like second or third round of the tournament. So those who criticize Gukesh, he was silently listen everyone. One of them was great player Magnus Carlsen also. He was also saying something wrong about the victory of Gukesh. Magnus Carlsen is also great player. He's also very great player. But Magnus Carlsen was also saying something bad about the Gukesh. He was not directly saying, but in indirect way he was trying to say that victory of Gukesh just was a fluke. After that, Gukesh played few matches with Magnus, and there Magnus win. Even though Gukesh was silent. After becoming world champion, he lost 2 matches against Magnus, even though he was focused. He was calm and cool. And recently, yesterday only, he won match against Magnus. He won match against Magnus Carlsen. What learning is there? What we are learning from this? Yeah, he defeated Magnus. Yeah, yesterday only. So what learning is there? If you are going to become world champion, even though people are there to say bad about you, in this type of situation, there is no need to react. There is no need to explain someone. Just be focused more than earlier. Be prepared more than earlier. Be more disciplined more than earlier. And prove yourself to others by your victory. This is the difference between winner and loser. Like we are oftenly we are saying, action speaks more than words. So those who are getting less marks, for them only one simple suggestion is there. Be cool, be calm, be disciplined, be focused for next 1 year. And prove yourself by your victory. Let's say this year you're thinking about some medical college, government medical college of a small ranking. Now think about big medical college. Why not think about the aims? Make your dream big, Nayar. If you're going to give 1 year, make big dreams. And you already started, this is the good part. This is the good part, okay? Okay. Chalo, so now let's start our preparation part. First, Okay. So in lecture number 1, of ABC chemistry, electronegativity was explained. In lecture number 2 and 3, hybridization was explained. Yeah. Sai is saying working hard in silence and let success make noise. Yes. Yes. Absolutely right. Okay, so in lecture number 1, electronegativity was completed, and lecture number 2 and 3 we discussed about the hybridization. If any one of you is having doubt in any of these topics which are discussed here in lecture number 1, 2, 3, you can ask. If any doubt is there related to the electronegativity concept or hybridization concept, you can ask. Any doubt? No. No doubt, no question, nothing. Very good. Okay. Sir, if we are very serious this time, we will get more marks in 2026. Undoubtedly. Undoubtedly. Okay. Chalo. So let's start new topic. Okay. Mohit Sai is saying crystal clear. That's good. Chalo. Very good. Okay. So we have to start new topic. It is inductive effect. See, when you're learning organic chemistry, few concepts are oftenly used, like inductive effect, hyperconjugation effect, resonance effect, electromagnetic effect, etc. This inductive, hyperconjugation, resonance effects, they are oftenly used to explain the stability of different intermediates in the organic chemistry. Other than inductive, hyperconjugation and resonance effect, we are oftenly discussing on two more important concepts in organic chemistry. They are electronegativity and octet. Okay. For now, we are going to discuss about the inductive effect. I will explain you about the inductive effect, and later on in the coming lectures I will explain you about the resonance effect. Resonance effect is also named as mesomeric effect. Very minute difference is there that will be discussed at the time of R effect. Okay, someone is asking, that's why I replied here. Okay, so now listen. So for now our topic is inductive effect, or I can write simply like this also, I effect. Inductive effect or I effect. Sir, how many days running basic part? Okay, so in this first part we have to cover 6 lecture in track 1 and 6 lecture in track 2. 3 lectures already over. This is 4th lecture. 2 more lectures are there. Then another team will come. And they will also take 6 lecture in track 1 and track 2. Chalo. Okay, let's come to the topic. So now, our topic is inductive effect. Our topic for today is inductive effect, I effect. Okay, so you tell me, what is inductive effect? Give some idea. What is inductive effect? Or tell me one thing. Let's say HCl molecule is given. HCl molecule is given. In this molecule, sigma electron density of chlorine is polarized towards, electron density of this bond is polarized towards chlorine. Chlorine is becoming delta minus, hydrogen become delta plus. Is it inductive effect? This is inductive effect or not? You have to answer. This is inductive effect or not? electron sigma bond density of HCl bond is polarized towards chlorine. Is it inductive effect? Yes or no? No, this is not inductive effect. This is not inductive effect. This is not inductive effect. Then sir, what inductive effect is? So I will explain inductive effect by one example. Assume we have molecule like this. This is carbon chain. This molecule is given to you. And whatever concept I am going to explain is given in the NCERT. Okay. So now this molecule is given to you. Now in this molecule, if you observe this carbon-chlorine bond, electronegativity of chlorine is more than carbon. And since electronegativity of chlorine is more than carbon, this sigma electron density is getting polarized towards chlorine. Out of carbon and chlorine, who is more electronegative? Chlorine. And if chlorine is more electronegative, this bonded pair electron density or sigma electron density is getting polarized towards chlorine. And due to this, delta minus charge develop on chlorine and delta plus charge develop on carbon. You are knowing one concept. If electron is coming near to some atom, it will acquire minus charge. And if electron is going away from some atom, it is going to acquire plus charge. So this sigma electron density move towards chlorine. So chlorine become delta minus and carbon become delta plus. Okay or not? Now listen the most important concept here. Now this carbon is a delta plus. This carbon is a delta plus. And if you observe, for now this carbon not having any charge. So now one is a carbon delta plus and one is carbon without charge. So it is very obvious, if delta plus charge is present, it is going to become electron deficient. Relatively, this is a relative term. If I compare these two carbons, this carbon is delta plus becoming electron deficient. Or I will make it easy. But this carbon is acquiring what charge? Delta plus charge. So plus will attract minus na yaar. Plus will attract minus and charge on electron is minus. So what will happen here? This carbon is delta plus and this carbon is not carrying charge. So this delta plus carbon is going to attract this sigma electron density. And because of this, delta plus charge develop on this carbon also. And plus charge develop on this carbon. I am giving number also. This is carbon number 1, this is carbon number 2, this is carbon number 3, and this is carbon number 4. So on carbon number 2, when carbon number 1 is getting delta plus charge, electron density is attracted towards this, and that is why plus charge develop on this carbon number 2. This charge on carbon number 2 is less than carbon number 1, so I will represent by double delta plus. Here double delta plus means less than delta plus. Double delta plus means less than delta plus. Now I will compare carbon, this carbon and next carbon. So here this carbon is delta plus and this carbon not carrying any charge. So this is going to attract, this carbon, this one is going to attract electron density. And if electron density is attracted towards this, here it is going to acquire, when electron density is attracted towards this carbon, this will acquire plus charge and this is less than previous one, so triple delta 1. And likewise I can write for next also 4 delta plus. Okay. What is important concept here? If I observe this molecule, in this molecule delta En difference is observed for this carbon chlorine bond only. Or I can simply say this carbon chlorine bond, this carbon chlorine, this part, carbon chlorine bond was polar and these bonds were non-polar. But due to the polarity of this carbon-chlorine bond, due to the polarity of this carbon-chlorine bond, polarity develop in next bond, adjacent bond also. Likewise, this bond also. This is inductive effect. So I will write two conditions here. Assume one condition, initial condition, and another condition I am writing here. Observe properly. Here carbon chlorine, chlorine more ion, chlorine delta minus, carbon delta plus. So this bond is a polar bond, you can easily observe. And here polarity is not present in the beginning. Because of the ion difference here, because of this ion difference, delta plus charge develop on this carbon, and now this is going to attract the electron density and delta plus develop on this also. So now polarity develop on this adjacent bond. This is actually inductive effect. So NCERT is clearly writing one concept. They are giving this molecule and they are saying, keep due to the polarity of carbon-chlorine bond, polarity developing adjacent bond. This is inductive effect. This is inductive effect. Why I am emphasizing in detail? Because sometimes we are thinking, let's say we have this type of situation, this is also inductive effect. No, this is not inductive effect. Because here what happened? Electron density moved towards chlorine, chlorine become minus, H become plus. This is polar bond. But this bond or this polarity of bond is not able to develop polarity on another bond. So that's why it will not be considered as inductive effect. Got the concept or not? Now I'll come to the properties of, so what we discuss here, we have bond like this, we have this kind of situation where CCl bond is polar and carbon-carbon bonds were non-polar, and due to the polarity of the CCl bond, polarity develop on adjacent bonds also. This is inductive effect. Concept is clear to you or not? What inductive effect is? Concept is clear to you or not? Is it clear? Reply quickly. Yes, very good. Okay, now come to the properties of inductive effect. Here I said one point, this delta plus is bigger than double delta plus. Double delta plus is bigger than triple delta plus, and triple delta plus is more than 4 delta plus. So what we can conclude, as I am moving away from chlorine or as I am increasing distance, inductive effect is drastically decreasing. So what is important concept here, as you are going to increase the distance, inductive effect will decrease drastically. Inductive effect is going to decrease drastically. This information is also important, because sometimes examiner may play with the statements, like you are knowing, as we increase distance, I effect is going to decrease. This concept is known to you. You are knowing, if we are increasing the distance, inductive effect is going to decrease. You are knowing. Now here, examiner may play with the statement, this decrease in the inductive effect with the increase of distance is a gradual decrease or drastic decrease. So answer is, it is a drastic decrease. Got the concept or not? And that is why after 3 bonds, inductive effect is almost 0. So I will count from this bond 1, 2 and 3. After 3 bonds for this one, I effect is almost 0. I am not saying exactly 0, almost 0. So by this information, what we can conclude, inductive effect is a distance dependent effect. Inductive effect is distance dependent effect. As you are going to increase distance, inductive effect is going to decrease drastically. And after 3 bonds, it is going to be almost 0. Okay, got the concept or not? So if you want to define inductive effect, what you will say? It is a development of polarity in a non-polar bond due to the adjacent polar bond. Due to the adjacent polar bond. Is it clear? and it is going to decrease drastically with increase of the distance. Is it clear or not? Understood the concept? And after 3 bonds, inductive effect is going to be almost zero. If we use more electron, after 3 bonds it is almost zero. After 3 bonds it is almost zero. Okay. I will come to the further detail of this inductive effect. Before that, let's observe what NCERT is saying about this. Yeah. This heading is given here, inductive effect. Can you observe? Yeah. Now, this example is given. There, they have taken this molecule. Okay. Now, what they are saying here, carbon number 1, I'm going to start from here. Carbon number 1, this one, carbon 1, which has developed partial positive charge delta plus, draw some electron density towards it from the adjacent CC bond. Means this carbon number 1 is going to attract electron density towards itself from the CC bond. Okay. Some positive charge double delta plus develops on carbon number 2 also, where double delta plus symbolizes relatively smaller positive charge as compared to on carbon number 1. Now here they are explaining what is the meaning of inductive effect. What they are saying, I will underline. In other words, polar CCl bond induces polarity in the adjacent bond. Such polarization of sigma bond caused by polarization of adjacent sigma bond is referred as the inductive effect. This part is very important. This part is very important. In this part, what they are saying, कि carbon chlorine bond in this structure, carbon chlorine bond is polar, chlorine delta minus carbon delta plus, and due to the polarity of this carbon chlorine bond, polarity is induced in the adjacent bond also, and this effect is known as inductive effect. Someone is asking about the I get 483 marks anyway. For this, please go to the Naren sir's video. Okay, it is discussed there only. This is not for this. Okay, chalo. So what is given here? This definition is extremely important, very important. So what they are saying, I am repeating again. In other words, the polar CCl bond, this CCl bond is polar. This CCl bond is polar. Polar CCl bond induces polarity in the adjacent bond. Polar CCl bond is going to induce polarity in the adjacent CC bond. Such polarization of sigma bond caused by the polarization of adjacent sigma bond is referred to as the inductive effect. Got the concept or not? Because if you want to justify why in HCl inductive effect is not there, what reason we have to give? Here HCl bond is polar. But this polar HCl bond is not able to develop polarity in the adjacent bond, or not able to induce polarity in the adjacent bond. That's why it is not inductive effect. Is it clear? Understood? Now, then they are writing here also. I will underline here also. Okay, see this line. The effect decreases rapidly as number of intervening bond increases and become vanishingly small after 3 bonds. Is it clear now? What they are saying, decreases rapidly. That's why I was saying drastic decrease is there with increase of distance. And after 3 bonds, it is going to become almost 0. That's why they are saying here, after 3 bonds it is vanishingly small, very small, little. Got the concept? Understood? Understood the clarity is there, what inductive it is? Okay, chalo. Now come to the different cases of inductive effect. In case of inductive effect, we have 2 type of I effects, plus and minus. Plus I effect and minus I effect. On what ground these names are given? So, plus effect means giving and minus effect means taking. Plus effect means giving and minus effect means taking. And by the previous discussion you can easily understand inductive effect is going to operate through sigma bond. Inductive effect is going to operate through which bond? Sigma bond. Okay or not? So what I can say, if any group is able to give electron density through the sigma bond, I can name it as a plus I. So I will say I effect of electron donating group is plus I, and I effect of electron withdrawing group is minus I. What does it mean? And one more point here, inductive effect of hydrogen H is assumed to be 0. I effect of H is assumed to be 0. So we can define in this way also, that those groups which are having inductive effect more than hydrogen are plus I, and those who are having inductive less than hydrogen, they are minus I. So 2 definitions can be given here for the plus I or minus I. One definition simple, you can say I effect of electron donating group is plus I, and I effect of electron withdrawing group is minus I. Another definition we can give based on hydrogen, कि by inductive effect of hydrogen is assumed to be 0. So those who are having I effect more than hydrogen are plus I. So plus I effect of hydrogen, which is 0, and then minus I. So you can define in this way also, that those groups which are having inductive effect more than hydrogen are plus I, and those who are having inductive less than hydrogen, they are minus I. Any of these 2 definitions you can use to explain plus I and minus I. Okay, for example, let's say I want to know about the plus I effect or plus I groups. I want to know about the plus I groups. So plus I means what? Giving or taking. Giving through sigma or taking through sigma. If someone is plus I group, means what it is doing? Answer quickly. Giving through sigma or taking through sigma? Giving, obviously, electron donating through sigma. So in case of plus I, 2 important cases are there. One is a negatively charged group, and another is saturated hydrocarbon. saturated hydrocarbon, and there is no need to memorize it, you will get by the concept, don't worry. Tell me one thing, let's say we have one group, let's say we have some group which is carrying negative charge. Any group is there carrying negative charge, and it is connected with some atom A through this sigma bond. This is sigma bond, okay? So this is sigma bond, and this is negatively charged group. This group is carrying negative charge. This is sigma bond. Bond means electron density. Electron is minus charge, you are knowing. So charge on electron minus. Charge on this group also minus, and minus minus repel each other or attract. Obviously minus minus repel each other. So what will happen here? Observe properly. This is a very important concept. Charge on this group is negative. Charge on this group is negative. And charge on these sigma electrons also negative. So negative charge on group is going to repel these electrons, yes or no? And because of this repulsion, they will go away like this. So what I can say for this group, what this group is doing, it is giving electron density to A. This group is giving electron density to A. Going like this, na? So for this group, I will use term plus I. Okay or not? Yeah, donating, you can say in this way also. Or you can make this thing very easy. If minus charge is given, if negative charge is given, negative charge is powerful, plus I, and if positive charge is given, if positive charge is given, it is powerful, minus I. You can make it easy by this also. Because sometimes in exam we don't have time to analyze the problem in a sufficient time is not there, so we can go for direct also. Like, and this is very easy to memorize. By minus charge powerful plus I, positive charge powerful minus I. This you can easily memorize. What do we have to memorize? Negative charge powerful plus I, positive charge powerful minus I, minus charge plus I, plus charge minus I. Minus charge plus I, opposite, okay? Minus charge plus I, plus charge minus I. So in exam, if you don't want to waste your time, you can go for this also directly. Minus charge is powerful plus I, and plus charge is powerful minus I group. So this is going to save your time, okay? So here, if you observe, sir, what is quark? Quark particle will explain to you in electrostatics. Physics people will explain you, okay? So now listen here. Negatively charged group, I said, what I have taken here, what heading is written here? Plus I effect. So if I have taken plus I effect, then obviously I will consider negatively charged group. So two cases are there which are oftenly used for plus I. They are minus charge group and saturated hydrocarbon. Negatively charged group, for example, it can be O minus, it can be NH minus, it can be COO minus, etc. Saturated hydrocarbon, for example, 3-degree group, like this, 2-degree group, these are plus I group. Okay, so one category is negatively charged group, they are plus I, powerful plus I, and another category is saturated hydrocarbons, which are written here. 3-degree, 2-degree, 1-degree, like that. Now, if I want to compare these three, then I will simply find how many groups are available to donate electron density there. So in this case, These three are available to give. Here 2 are available, here 1 is available. So obviously this 3 degree has more plus I than 2 degree and 2 degree more than 1 degree. And out of ethyl and methyl, ethyl is more. Okay or not? Now if I want to compare negative charge versus saturated hydrocarbon, who will repel more? Who will give electron density more easily? Minus will give more easily or neutral will give more easily? So obviously minus will give more easily. And don't memorize na. Just now we discuss here. Minus charge group, minus charge on electron repel each other. So electron is going away from the group. Or better, easier, most simple way to understand, negative charge powerful plus I. Negative charge powerful plus I. So if I compare here saturated versus positively negatively charged, then negatively charged group is having more powerful plus I effect. Okay or not? So this is one concept. Next and very important concept, if you want to compare plus I effect of isotope related molecules like CT3, CD3 and CH3, then plus I effect of CT3 is more than CD3 and CD3 is more than CH3. Plus I effect of CT3 more than CD3 and CD3 more than CH3. Okay or not? So this is about the plus I. So for plus I simply said one concept, plus I, negative charge is more than saturated hydrocarbons. Negative charge cases can be O minus, can be NH minus. Okay, can be CO minus, and saturated hydrocarbon cases already explained. Okay, now come to the next case, minus I. Minus I. Minus I effect. Minus I effect. Minus I effect. Minus I effect. Okay. One question is coming here, sir. How the inductive it changes due to neutron change in isotopes? Please explain it. Okay. Remind me to explain this thing at the time of hyperconjugation effect. At the time of hyperconjugation effect, just remind me. I will explain what is the reason why CT3 has more inductive than CD3 and CD3 more than CH3. Because at that time I will go for the detailed concept of this. Okay. So now come to the minus I effect. Come to the minus I effect. Minus I effect. Electron donating or electron withdrawing? Electron donating or electron withdrawing? Please answer. Donating or withdrawing? Donating or withdrawing? Answer quickly. Yeah, electron withdrawing. So I effect of EWG. Chalo, no problem. Now, one simple method I said to analyze, that was plus charge, positive charge, powerful minus I, and negative charge, powerful plus I. So here, what is written here? Plus minus I effect is written. Heading is minus I effect. Minus I effect. So what you want to take here? Plus charge or minus charge? Minus I effect. This name of the topic is minus I effect. So what do you want to take? Plus charge or minus charge? Obviously plus charge. So here, maximum minus I effect. So for minus I effect, simply positive charge will come maximum. Then delta positive charge will come. And after that electronegativity will come. Or electronegative atoms will come. High EN atoms will come. Okay or not? Now, in case of positive charge, In case of positive charge, many possibilities are there. For example, it can be NF3 plus, it can be NR3 plus, it can be SR2 plus, it can be NH3 plus, and many more. In all cases, you can find this group contain positive charge. Delta positive cases, for example NO2, for example SO2R, CN, C double bond OH, C double bond OH, C double bond OH, like that. So how is delta positive? Observe this also, no problem, we'll get it. See, out of oxygen, nitrogen, who is more En? So obviously oxygen. So oxygen will acquire minus and will acquire delta plus. Out of sulfur, oxygen, sulfur more En. So oxygen is more En. So oxygen delta minus, sulfur delta plus. Out of carbon, nitrogen more En. So nitrogen minus, carbon delta plus. Here this carbon delta plus, here this carbon delta plus. So what you are observing, in this case, the atom who is attached to the desired carbon chain is containing delta positive charge. See this here, N delta plus, S delta plus, C delta plus, C delta plus, C delta plus. Okay, when you come for the offline, at that time I will explain you trick also to memorize this thing in a sequence. For now, I don't want to explain because for recent discussion this is not required, but in detail it is required. So later on in main track I will explore, at the time of main lecture I will discuss sequence or trick also to memorize in a sequence. Okay, then electronegative atoms will come. For example, fluorine, chlorine, bromine, iodine, like that. Okay, oxygen like OR, OH, and nitrogen like NH2. Okay, and many more I can write. In fact, double bonded carbon also. These are electro high En atoms. So this is the sequence of minus I effect. So what we discussed till now, first we discuss about the definition of inductive effect. Definition of inductive effect. Definition of inductive effect. How we can define? How we can define induction of the polarity in a bond due to adjacent polar bond. Simple, one line answer. Second, inductive effect rapidly or drastically decreases with the distance. Inductive effect rapidly or drastically decreases with increase of the distance. Next point, after 3 bonds, inductive effect is negligible, very less, very small. Next, in case of nature of I, we have 2, plus I and minus I, plus I and minus I. If you want to go for plus I, then what do you take, minus charge or plus charge? So you are knowing trick, by this you can find if it is a plus I effect, we have to take minus charge, and if it is minus I effect, I have to take positive charge. Okay or not? So these concepts are discussed here. Now based on this, we can easily find flow of electron in a given molecule. I will write one simple example by which you will understand how to represent effect of a group based on the nature. I have taken this molecule here, CO minus is attached, here Cl is attached. Let's say here I am going to attach NO2 group. Okay, here I will take O minus. Okay, and here I will take OH, and here I will take COOH. And for each case you have to represent electron, direction of electron for inductive effect. And there is no need to memorize, you can find it. You can find it with the logic. You can find it with the logic. For example, here CO minus is given. CO minus is given. Minus charge is going to attract electron or going to repel electron. Minus charge is going to attract sigma electrons or going to repel sigma electrons. Attract or repel? Just answer one thing. Repel, obviously. Charge, minus charge on CO, it is minus charge, and electron also minus repel. And when this is going to repel, it will go like this, na? So here I will represent in this way. This is chlorine. Chlorine means high En atom. Or in knowing also, this is sp3 carbon and this is chlorine. En of chlorine is more than sp3 carbon. So this is going to attract, here I will draw like this. NO2, observe, nitrogen, oxygen, all are high En atoms. All are high En atoms. They are going to attract electron density towards themselves. So NO2, all these atoms are going to attract the sigma electron density. So I will draw like this. O minus, attract or repel. O minus, attract or repel. O minus. O minus, attract or repel. O minus, charge on O minus. This is minus charge. This is minus charge. And here electrons are also minus charge. Minus of O and minus of electron, they will repel each other, na? So I will represent here electron going away from this. Now observe, this is OH. It is electronegative atom. This is going to attract. Observe this thing, COOH. COOH. Oxygen, they are high En atom. This carbon delta plus also. This is going to attract electron density. So logically I can draw direction for the polarization of sigma electron density. Okay or not? Don't memorize, you can find it. What is given here? COO minus. COO minus. Charge on group minus. Charge on electron also minus. Minus repel each other. So this sigma electron density is repelled. So go away from the CO minus. While if I take COOH, this carbon is delta plus. And these oxygens are electronegative atom also. So this is going to attract sigma electron density towards itself. I will compare these two also for the clarity. Here it is O minus, charge on O minus, charge on O minus, minus repel. So this minus will repel this sigma electron density. So we'll go away from O minus, I will represent like this. While in case of OH, En of it is high En atom, it will attract sigma electron density towards OH. So by looking the group only, we can easily find out correct direction for the polarization of sigma electron density in case of inductive effect. Okay, chalo. Now here I will write few structures with the polarization, and you have to find out which one is representing correct flow of the electron density in terms of inductive. Okay, you have to find correct direction of inductive effect. First molecule, second, fourth, fifth, five, six. Next example. Next. Okay. These many examples are enough to understand the concept. Chalo. Okay. Now, in case of 1 and 2, which one is correct? 1 and 2. Out of 1, 2, which one is correct? Answer one by one. Answer one by one. Out of 1 and 2, which one is correct? 1 or 2, which one is correct? The tactical titan is saying 2, others said 1. Okay. 1. Only one student said 2, others said 1. See, it is very obvious now. Chlorine is electronegative. So it will attract electron density. So here, En of chlorine is more than this carbon here. So electron density, it is electronegative atom. So electron density move towards chlorine. Sigma electron density is attracted towards chlorine. This is true. While in this case, what is represented? Electron density is going away from electronegative. Not possible. So out of 1 and 2, which one is correct? 1 is correct. Now go to the 3, 4. Out of 3, 4, which one is correct? Out of 3 and 4, just observe. Take your time. Take your time, then answer. Take your time, then answer. Out of 3, 4, which one is correct? 3. Very good. Anyone is saying 1? If anyone, okay, 3. Very good. Here also same concept. Okay, tell me one thing. Simple question. electronegativity of oxygen versus carbon, who is more? En of oxygen versus carbon, who is more? Obviously oxygen. So this is also high En atom. It is also high En atom. Since it is high electronegativity atom, this is attracting sigma electron density. OH is attracting sigma electron density towards itself. And then other, this is attracted and like this. So 3 is correct, 4 is wrong. Okay. Number 5. 5 versus 6. 5 versus 6. Which one is correct? 5 versus 6. Which one is correct? Observe properly and then answer. Take your time. Take your time. Nice answers are coming. Very good. I'm impressed. Very good. 5, 5, 5, 5, 5. Okay, 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 okay. Nandi said 6. Jagdish also said 6. Remaining said 5. Okay, Jagdish answer one thing. Jagdish and Nandi. Jagdish and Nandi, please answer one thing. Charge on NH3 is plus. Charge on NH3 is plus. And if charge on NH3 plus, 1 minute, some problem. Just give me 1 second. Okay. 1 minute. Yeah. Charge on NH3 is plus. Charge on NH3 is plus here. And if this is plus charge, you have to answer. If this is plus charge, this is going to attract the sigma density or will repel? Answer one thing. Charge on NH3 is plus. Charge on NH3 is plus. So it will attract electron density or it will repel electron density. Nandi. Okay. Jagdish, answer please. Jagdish, I'm waiting for your reply. Attract. Yes, attract. Okay. Chalo. So now if it is attracting, if it is going to attract, if this NH3 plus is going to attract, electron density will move towards NH3 plus here. And what is represented here? This electron density is going towards NH3 plus. Attracted towards NH3 plus means this is correct. So this is wrong. So now go for the next case. 7 versus 8. 7 versus 8. Which one is correct? 7 versus 8. Which one is? Observe. See, don't answer immediately. Take some time. Take few seconds. And then answer. No problem. If not getting immediately, no problem. Take some time and then answer. 8, 8, 8, 8, 8. Very good. All are saying 8. 8. Very good. Very good. Very, very, very good. 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 8. Chalo. Very good. 8. Yeah. 8. 8. Okay. What logic we can produce here? Charge on COO minus. Or minus charge written here. See, minus charge. See, this is minus charge. This is minus charge. And charge on electron also minus. Minus, minus repel each other. Charge on COO minus. Charge on COO minus. Charge on electron also minus. Minus, minus repel each other. Minus, minus repel each other. Minus, minus charges are going to repel each other. So negative charges are repelling each other. Which one is representing? Electron repelling means going away na yaar. So out of 7 and 8, which one is representing electron density is going away from CO minus? So answer is 8. Here you can check. This electron density is going away from CO minus. Going away from CO minus. So here 8 is correct and 7 is wrong. 8 is correct, 7 is wrong. ठीक है? Understood? Got the concept? Chalo. Now move to the 9 versus 10. Answer in this case. Out of 9 and 10, which one is correct? Someone is saying voice is breaking. Now is it okay? Okay, all are replying. Okay. Chalo, very good. Siva Prasad said at 10. Siva Prasad said 10. Others said 9. 9. Others said 9. Only one student said 9. 10. Yeah. Chalo, no problem. ठीक है. Good. Good. 9. Correct answer is 9. Yeah. 9. Okay. ठीक है. 9. Good. Okay. One more student said 10. Others said 9. Only 2 students said 10. Okay. Others said 9. No problem. You can get it. Okay. First of all, tell me one thing. On this COH, any charge is present like positive charge or negative charge? Any charge is present on this COH or on this COH? Any charge is present here, positive or negative? Yes or no? No. There is no charge like plus or minus here. Then how we can analyze? So 2 ways are there to analyze. One simple way, this oxygen, they're high in atom. This carbon is also high in sp2 carbon. So this is going to attract electron density. Another method, you can go for the structure. Someone is asking question to me, that's why I'm explaining this thing. One student asks, sir, explain it again. No problem. Listen, this is given. So here, Siva Prasad, okay, sir. Understand, they don't repel. Okay, you understood. So voice is interrupting. Let me check. Battery is okay. Okay, some network problem may be there. Okay, now voice coming. Voice coming. Coming or not? Okay, or I can check on my YouTube. Okay, no problem. Yeah, it is coming. Yeah, okay, no problem. Chalo, theek hai. Listen properly. This compound is given. Here, out of this oxygen carbon, who is more En? Obviously, oxygen is more En. So oxygen will acquire delta minus, and this carbon will acquire delta plus. Here also, out of this oxygen carbon, who is more En? Oxygen. So oxygen acquire minus, and this carbon will acquire delta plus. So this carbon is plus. Because of delta plus charge on this carbon, this sigma electron density is attracted towards this COOH, and that's how this become minus I group. Okay, so now observe here. This COH is minus I. It is attracting sigma electron density towards itself. So this is correct, and 10 is wrong. See why concept is important. Check, when I have taken COO minus, electron density is going away from CO minus. Means here CO minus is going to act as plus I. But when I am taking COOH, electron density is going towards COH. It is becoming minus I. That is why knowing concept is very important. Okay. 11 versus 12. Which one is correct? 11, think properly, then answer. Give some time for this particular 11 versus 12. Okay. 11, 12, 11, 12, 11, mixed answers are coming. And if I say, oh my God, 11, 12, mixed answers are coming, 11 versus 12. Look at properly. Okay, chalo, theek hai. Now if I say both are wrong, this was trick question. That's why we are covering all possibilities where examiner may trap you. Both are wrong. You understood why? Both are wrong, yeah. 11, 12, both are incorrect representation. Both are wrong. You understood or not why? Can you figure out what is the reason? Why 11, 12 both are wrong? Arrangement. Is it carbocation? Why are you saying arrangement take place? Anyone? 11, 12 both are wrong. Yeah, Ponanjali said sp3 carbon, no EN difference. Tarini Pandey said no EN difference. Correct answer. Ponanjali said sp3. Shayan Ali also said sp3. Correct answer. No polar carbon bond. Naruto, you're right, but a little bit changed. No polar carbon bond, you can say. Both are sp3. All carbons are sp3. Radha Gopi, correct. Sai Srikant, correct. Jayesh, it is CS3. I'll come to Jayesh's point of view. No, don't worry. Okay. Yeah. Okay. Almost all are able to figure out why both are wrong. Here, this question I gave just to trap you, okay? Because what I want, do mistakes before exam, before NEET exam, but don't do mistakes at the time of exam, okay? Main exam, NEET exam there. Observe here. Here all the carbon atoms are sp3 hybridized. All these are hydrogen atoms. All the carbon atoms, any carbon atom, if you observe, they're sp3 hybridized. All the carbon atoms are sp3 hybridized. So there is no EN difference created. And that is why there is no inductive effect operated here. So in case of 11 and 12, inductive effect is not present. In case of 11 and 12, inductive effect is not present. And to justify or to clarify this particular 11 versus 12, next example 13 versus 14 taken. Here you can observe this carbon is sp3, this carbon is sp2. Here also I can write same thing, sp3 and this carbon sp2. sp2 carbon has more En than sp3. You are knowing electronegativity of sp3 carbon is less than sp2 carbon. As you know, sp3 carbon roughly 2.5 and sp2 2.75. So that's what I said at the time of electronegativity. Why En was discussed in the beginning only? Because I said in the beginning only कि negativity, hybridization. These are the concepts which are oftenly or frequently used in the organic chemistry here. Not only organic chemistry, in many places we are using these concepts. That's why we are learning basics before going in the detail of any particular topic. So here, this carbon is sp2 and this carbon is sp3. sp2 carbon electronegativity is 2.75 and sp3 carbon 2.5. It is very obvious electron density moved towards sp2. So this is correct and 14th become wrong. So 11, 12, 13, 14. These four examples are explaining about the inductive effect for carbon-carbon cases also. If all are carbon atoms only, obviously hydrogen is also present, but inductive of hydrogen is assumed to be 0. ठीक है ना? Then how to think? Now someone is saying, sir, you said CS3 is plus I group. Yes, CS3 is plus I group. CS3 is plus I group, undoubtedly. But it must be attached to someone to whom it can give electron density in air. For example, if CS3 is attached to another CS3, here inductive is not present. No inductive. But if it is attached to someone, for example, CS3 is attached to this benzene structure. So now here, this is sp2 carbon, this is sp3 carbon. Now here CS3 will give act as plus I. There's a difference here. Here this carbon is sp3, this carbon is also sp3. En difference is not present. While in this case, this is sp3 and this is sp2. And sp2 carbon is more electronegative. So electron density is attracted towards CS3, this sp2 carbon. So CS3 is giving electron density. So CS3 is going to act as plus I group. Got the concept or not? So someone was asking, is it clear to you? Yeah. Mohit Sairam, you understood the concept? Mohit, you understood the concept or not? Chalo. Okay. Okay, one doubt came here. Sir, if we break double bond and negative charge will come on the carbon. If it is negative charge, then it is intermediate. For intermediate, we have to discuss later on, don't worry. In case of intermediate, like carbocation, carbanion, carbon free radical, how to find their stability, how to represent the movement of electron density, all these concepts will be discussed in detail. Okay, here we are going to deal general organic chemistry, where we are discussing about, at the time of main track obviously, at the time of main track, we are going to discuss on chapter general organic chemistry, where we will discuss or we will explain you detail about the intermediates, carbocation, carbanion, carbon free radical, carbene, nitrene, and many more. Their stability, their generation and everything. At that time we will get it, don't worry. Okay or not? Okay, so this is clear to you what inductive effect is? Understood or not? Okay. ठीक है? Okay, चलो. So in today's lecture, I effect is completed. See, only concept related to the I effect is completed. But its application will be used many times. Application of I effect will come many times. Voice is not coming properly. Oh my God. Okay, no problem. Chalo. So now I'm going to stop here only. In next lecture, I will explain you hyperconjugation effect. Before that, those who were absent, please revise lecture number 1, lecture number 2, lecture number 3, and today's lecture also means lecture number 4. Or those who came late, for them also you have to watch all these lectures. Okay, so we'll close today's lecture here only because some voice problem also coming there. Okay. Okay, some problem is there. Chalo, okay, bye bye, take care, bye bye.